Honda has just revealed the truth behind Aston Martin's supposed early engine sign-off, and it is far more dramatic than anyone expected. The new power unit was not approved ahead of Mercedes, Ferrari, Audi, or Red Bull powertrains. Every manufacturer faced the same March 1st homologation deadline, while Honda pushed development until the final possible moment. Then, the nightmare began. Battery failures, violent vibrations, repeated retirements, and warnings that the steering wheel could cause long-term damage to the driver's hands. But after emergency work at Honda's Sakura facility, Fernando Alonso delivered the message that could change Aston Martin's entire season. The vibrations were gone. Now the biggest question is whether Honda has finally saved Aston Martin's new era, or only hidden a deeper failure waiting to strike again. Subscribe to the channel. To understand why this revelation matters, you have to begin with the one detail the headline gets wrong. Honda did not receive an early sign-off. There was no special approval. No private advantage. No extra window that Mercedes, Ferrari, Audi, or Red Bull powertrains did not receive. Every manufacturer faced the same homologation deadline. March 1st, 2026. That date locked the basic foundation of each new power unit under the regulations. And Honda did not reach it with weeks to spare. According to the source, Honda kept developing until the very last moment. That changes the entire meaning of the story. An early approval would suggest confidence. A finished design. A manufacturer so comfortable with its work that it could stop before everyone else. But Honda arrived at the deadline under maximum pressure. And once the season began, Aston Martin discovered just how little margin the project really had. The new engine did not simply lack speed. It began creating failures serious enough to end races. Battery problems appeared. Violent mechanical vibrations traveled through the car. Electrical systems came under enormous stress. And the driver started feeling the consequences through the steering wheel. That is where the story becomes much bigger than one engine deadline. Because the new power unit regulations created one of the most difficult engineering challenges Formula One had ever seen. The electrical side of the engine became far more important. The motor generator unit connected to the turbo was removed completely. The electrical motor linked to the rear axle became dramatically more powerful. Its output rose to roughly 470 brake horsepower. The combustion engine produced around 540 brake horsepower. That meant the electrical system was no longer a small supporting part of the car. It was becoming almost equal to the combustion engine in importance. And that placed extraordinary pressure on the battery. The battery had to release massive amounts of energy. It had to recover energy under braking. It had to survive extreme heat. And it had to do all of that while the car attacked curbs, changed direction, and shook violently for lap after lap. Imagine asking a phone battery to power an entire house. Then imagine shaking it continuously while it works. That gives you some idea of the challenge Honda faced. But the biggest problem was not simply the amount of energy. It was what the power unit was doing physically inside the car. The source points to severe mechanical vibration. Those vibrations did not stay inside the engine. They traveled through the chassis. They moved into the steering column. They affected the battery and control systems. And eventually, they reached Fernando Alonso and Lance Stroll through their hands. That changed the situation completely. A slow engine costs lap time. A broken battery causes a retirement. But violent vibration can attack several parts of the car at once. It can stress sensitive electrical components. It can weaken connections. It can make the steering feel unclear. And it can physically hurt the driver. Adrian Newey reportedly warned that prolonged vibration through the steering wheel could risk long-term nerve damage to the driver's hands. That is not a complaint about comfort. That is a safety warning. Imagine gripping a powerful machine that shakes constantly. At first, it feels irritating. Then your hands begin to tire. Then numbness can start. Now imagine experiencing that while driving a Formula One car at enormous speed. You are braking at the limit. You are correcting small slides. You are managing energy deployment. You are protecting the tires. You are communicating with the team. And the steering wheel is sending repeated vibration into your hands for the entire race. That affects concentration. It affects precision. And most importantly, it affects trust. A Formula One driver relies on the steering wheel for information. Good. Balance. Movement. Warnings. But when the car is shaking violently, those signals become harder to read. The driver no longer receives a clean message. And once that clarity disappears, confidence disappears with it. But here is where the problem became even more dangerous. The vibration may also have been connected to the battery failures. Mechanical vibration can place repeated stress on sensitive components. Connections can weaken. Internal parts can suffer damage. A system that survives one impact may fail after thousands. Think of bending a paperclip. One bend may not break it. A second may not either. But keep bending it, and eventually the metal gives way. The same basic principle can apply inside a racing car. If the vibration occurs at the wrong frequency, it can repeatedly attack the same weak point. And eventually, that weak point fails. That may explain why Aston Martin's early problem seemed connected. The car was shaking. The battery was failing. The electrical system was under pressure. And the drivers were suffering physically. The team could not be certain whether it was facing several separate weaknesses or one deeper problem spreading through the entire machine. That uncertainty made the crisis much harder to solve. A single broken part can be replaced. A system-wide vibration problem is different. Engineers have to discover where it begins, how it travels, which parts amplify it, which components suffer most, and whether the chassis and power unit are making each other worse. Honda could not solve that problem alone. Aston Martin could not solve it alone either. The engine and the car had to be treated as one complete system. And the opening races proved how urgent that work had become. In Australia, Fernando Alonso retired after only 15 laps with a technical issue. The team told him to stop the car. Lance Stroll also suffered engine-related problems and finished unclassified. One race into the new partnership, and both cars had already encountered serious trouble. That was the first warning. But one difficult weekend can happen. New regulations expose problems that simulations do not always reveal. New engines create unexpected failures. Every manufacturer expects some early pain. Then came China, and the situation became impossible to dismiss. Stroll retired after only 9 laps with a suspected battery failure. Alonso continued longer, but the vibrations became so severe that he said he physically could not continue much longer. He retired around lap 32. 2 cars. 2 retirements. 1 suspected battery failure. And 1 driver physically struggling with the vibration. Honda's response was unusually blunt. There was no excuse. That statement mattered. Manufacturers usually protect themselves with careful language. They say the issue is being investigated. They say the data will be studied. They say lessons will be learned. Honda removed the protection. There was no excuse. That revealed how far below expectations the project had fallen. The power unit was not delivering the reliability Honda had promised. The drivers could not trust the car. And Aston Martin's new era was already turning into a crisis. But the next race made the situation even more confusing. At Suzuka, Alonso finally completed his first full race distance of the season. That should have felt like progress. Instead, he finished 18th. The car survived. It did not compete. And Stroll did not reach the finish. He retired on lap 30 with a water pressure failure connected to the combustion engine. That was described as a new failure mode. Those words should worry any Formula One team. A known problem can be studied. It can be reproduced. It can be attacked with a specific plan. A new failure mode means the list is growing. First, the battery. Then, the severe vibration. Then, the physical strain on the drivers. Now, water pressure. Aston Martin was no longer chasing one weakness. It was chasing an entire chain of them. And every new failure consumed time that should have been used to make the car faster. That is the hidden cost of poor reliability. A Formula One race is not only a competition, it is also a test. Every completed lap gives engineers information. Battery temperature, energy recovery, tire wear, cooling demand, gearbox behavior, balance changes. But a car that stops early cannot complete the experiment. The team loses the most valuable data. It is like trying to measure how long a battery lasts, then switching the device off after 10 minutes. You can study the beginning. You cannot understand the full cycle. Aston Martin needed complete races to learn. The car kept failing before those answers arrived. And while Aston Martin was stopping, the rivals were collecting information. Mercedes learned. Ferrari learned. Audi learned. Red Bull powertrains learned. Every finish gave them another layer of understanding. Aston Martin was losing more than points. It was losing development time. That is why the extended break before Miami became so important. Aston Martin and Honda used that period to attack the vibration problem directly. A car was sent to Honda's Sakura facility in Japan. That decision showed how serious the emergency had become. This was not a small software correction. Honda needed the physical car. The engineers needed to understand how the power unit behaved inside Aston Martin's chassis. Where the vibration began, how it traveled, where it became stronger, which components absorbed the punishment, and whether Aston Martin's installation was amplifying Honda's problem. The engine and chassis could no longer be treated as separate machines. Honda built the power unit. Aston Martin built the car around it. If the engine produced a vibration, the chassis could carry it. If the mounting system reacted badly, the vibration could spread further. If the battery sat in a vulnerable position, repeated stress could damage it. The team could blame Honda. Honda could blame the installation. But blame would not finish a race. Both sides had to solve the complete system together. And by Miami, Aston Martin finally received the first clear sign that the work had produced something real. Alonso was asked about the vibration. His answer was simple. Gone. He repeated the point. He would say it was gone. Those words may have been the most important update of Aston Martin's season. Not because the car suddenly became fast. It did not. Not because Honda suddenly had the strongest engine. The source does not support that. The importance came from the process. A serious problem had been identified. The drivers had described it. Newey had warned about it. Honda and Aston Martin had studied it together. The car had been taken to Sakura, and Alonso could finally feel a clear improvement. That is how Formula One development is supposed to work. Problem. Investigation. Solution. Confirmation. Miami became Aston Martin's first completely clean weekend of the season. Both cars completed the sprint. Both cars completed the Grand Prix. The finishing positions were poor. But after Australia, China, and Japan, survival mattered. The engineers finally collected complete data. The drivers experienced the power unit over a full distance. And Honda gained evidence that the vibration work had made a real difference. For the first time, Aston Martin could begin thinking beyond immediate survival. But fixing the vibration did not fix the entire car. It only revealed the next weakness. And that next weakness would prove that Honda's biggest breakthrough was only the beginning of a much longer fight. That next weakness was the gearbox. And for Fernando Alonso, the problem was not subtle. He described the gearbox behavior in Miami as almost impossible to drive. That sounds like a separate issue from the Honda vibration. But inside a Formula One car, nothing is truly separate. The engine produces power. The electrical system adds its own power. The gearbox transfers that force to the rear wheels. And the driver must control the entire process with extraordinary precision. If one part of that chain behaves unpredictably, the car becomes difficult to trust. Imagine pressing the accelerator in a normal road car. You apply a small amount of pressure, and you expect a small response. You press harder and the car accelerates more strongly. The relationship feels natural, predictable. A Formula One driver needs that same relationship, but with almost perfect accuracy. At the exit of a corner, the rear tires are already close to their limit. The driver begins applying power while the steering wheel is still turned. If the power arrives too aggressively, the rear tires can lose grip. If it arrives too slowly, the car loses acceleration.